Hello students. In applications of uniform circular motion, this is our second video. In this video, we are going to discuss well of death. It is a picture of a well of death. As you observe student, the radius of the well increase from bottom to top. So that for the discussion, we are going to consider a part of the well of radius r. Now students, let's understand what is well of depth. A vertical cylindrical wall of a radius r, inside which a vehicle is driven in horizontal circle. Let's find out the forces act on the vehicle. Let m be the mass of the vehicle. Here we consider mass as a point mass. R is the radius of the horizontal circular path. V is the speed with which the vehicle is performing circular motion. Weight mg of the vehicle acts vertically downward. Frictional force acts along the wall of the well in vertically upward. Normal reaction acts horizontally towards the center of the well. And lastly, centrifugal force acts horizontally outward. Note down student, here we consider non-inertial frame of reference. Now let's understand balancing condition for vertical forces. Weight of the vehicle acts vertically downward, but the vehicle does not slide downward. It is because frictional force between the vertical wall and tires. Note down, it is a static friction that has a prevent slipping of the vehicle. So that student, the balancing condition for vertical forces should be weight of the vehicle equal to the force of a static friction. When they are equal, then there is a no net acceleration along vertical direction. It means there is a no sliding of the vehicle in a downward direction. But mg, that is the weight of the vehicle, is a fixed value. So what is a variable is the force of a static friction. The force of a static friction changes with the change in speed. It can take any value between the 0 to limiting force depend upon the value of the speed. Therefore, the condition for the motion of the vehicle to move without slipping is weight of the body should be less than or equal to limiting force of a static friction, because the limiting force of a static friction is the maximum limit of a force of a static friction up to which the vehicle can move without slipping. Now balancing condition for horizontal forces. As the vehicle performs circular motion, it is acted upon by centripetal force. This necessary centripetal force provided by normal reaction. This normal reaction is exerted by the wall of the well on the vehicle, so that the vehicle tries to get pulled towards the center of the circle. This is the direction of the circular path along which the car is moving. This is the direction of motion tangent to the circular path. As you observe student, the car takes turn on the left side, but car tries to keep itself on the right side. So it is because there is a centrifugal force which acts on the body, which try to keep the body in contact with the wall. So the centrifugal force keeps the vehicle in a contact with the wall. Now the condition for horizontal circular motion. Centripetal force must be equal to centrifugal force. So the centripetal force provided by the normal reaction equal to centrifugal force mv square upon r. But student, normal reaction has a fixed value. So here variable is the centrifugal force. Centrifugal force is equal to mv square upon r, which changes with the change in speed. Now let's discuss the net force acts on the vehicle. The balancing condition for the vertical motion of the vehicle is mg less than or equal to limiting force of a static friction. The balancing condition for the horizontal motion, that is normal reaction, is equal to centripetal force mv square upon r. But student, as we already discussed, normal reaction and that of mg has a fixed value, and centrifugal force and that of a force of a static friction changes with speed. Therefore, student, the speed of the vehicle should be such that it would provide force of a static friction equal to weight of the vehicle and a centrifugal force equal to normal reaction. If once the given speed provide force of a static friction equal to the weight of the vehicle, then the further increase in speed does not increase force of static friction. But the centrifugal force change with the change in speed, since the centrifugal force is the inertial force. From this discussion, we can see, student, centrifugal force and the force of a static friction change with speed. But out of the two, centrifugal force has no any upper and lower limit. But for that of a force of a static friction has a lower as well as the upper limit. Therefore, the vehicle should move with minimum speed which satisfies condition mg less than or equal to limiting force of a static friction. But we know, student, limiting force of a static friction is equal to mu s into n, where n is the normal reaction. But we know, student, second condition for the motion is n is equal to mv square upon r. Now let's substitute the value 2 in equation number 1. We have mg less than or equal to mu s into mv square upon r. The mass of a vehicle get cancelled. So we have v square greater than or equal to rg upon mu s. So v is equal to greater than or equal to under root of rg upon mu s. So the vehicle should be moved with the speed greater than or equal to under root of rg upon mu s. So the minimum value of the motion is v minimum equal to under root of rg upon mu s. Minimum angular speed. As we know, minimum speed is equal to under root of rg upon mu s. But v is equal to r omega. So r omega minimum is equal to under root of rg upon mu s. So in v is equal to r omega, r is a constant and omega, that is angular speed, changes with the change in the speed v. So omega minimum is equal to under root of rg upon r square into mu s. Here, student, we transfer r into denominator and I take a square of that so that I can put it into the square root. So the final value omega minimum is equal to under root of g upon r into mu s. This is the formula for the minimum angular speed for the vehicle. Now minimum frequency. Omega minimum, that is angular speed, is equal to under root of g upon r into mu s. But omega, that is angular speed, is equal to 2 into pi into f, where f is the frequency. So 2 pi f minimum is equal to under root of g upon r into mu s. After simplify, we have f minimum, that is the frequency minimum, is equal to 1 upon 2 pi under root of g upon r into mu s. This is the formula for the minimum frequency of a rotation of the vehicle. Maximum periodic time. Now why we consider the maximum periodic time? As the frequency has a minimum value, the relation between the frequency and that of the periodic time is f minimum is equal to 1 upon t. So if the frequency is minimum, periodic time should be maximum because they are inversely proportional to each other. So I can write T max is equal to 2 pi under root of r into mu s into, so that I can write T max is equal to 2 pi under root of r into mu s upon g. This is the formula for the maximum period of a rotation for the vehicle. Now student, very important case that we are going to discuss over here. Up till now we discussed that there must be some minimum speed with which the vehicle have to move in a well of the depth. But there is no upper limit of the speed. So suppose that if the speed of the vehicle is greater than the minimum speed under root rg upon mu s. Now student, for minimum speed, mg is equal to fs, that is force of static friction. As we already discussed, once the weight of the vehicle get a balance with the force of static friction for the given speed, there is no any increase in the force of static friction, even it is depend upon the speed. Once these forces mg and fs get balanced, there is no change happen even though there is an increase in speed. So that we can say student, they do not depend upon the speed. But increase in speed increase centrifugal force. Why only centrifugal force? Because the normal reaction has a fixed value. Only centrifugal force depends upon the speed. It can take any variable value depend upon the speed. Due to increase in speed, centrifugal force increase and slide the vehicle outwards, which increase the radius of the circular path. Because of the increase in radius, centrifugal force decrease. If the decrease in centrifugal force is such that it matches with the value of n, that is a normal reaction, then the vehicle again performs circular motion. Here what actually happened is student, because of the increase in centrifugal force, inertial force increase, which is not get balanced with the normal reaction which has a fixed value. So that the centrifugal force tries to push the vehicle in outward direction. Because of that, the radius get increased. Due to increase in radius, centrifugal force start decreasing. When the decrease in centrifugal force again get matched with the normal reaction, it start performing along the circular path instead of a sliding outward direction. So that if you observe in the picture of the well of death, the radius of the well is increased from bottom to top. If you increase more the height of wall, you can achieve any possible speed for the motion. Hope you understand the concept, student.